Welcome to
The
Rumbletop.
Trademark. I'm Thomas.
I'm Paris.
I'm Val.
I'm Ben.
I'm Aldwin.
Our roles in this project: I am the project manager in CAD. Paris is financial manager, coding and electronics. Val is design and manufacturing. Ben is manufacturing, and Aldwin is manufacturing and electronics.
Our performance requirements include collecting 50% of the dry debris on the table after 1 minute of operation on a 5 foot by 2.5 foot table. It leaves a trail of moisture but absorbs 90% of the water that it puts down. It moves at a pace of at least 30 centimeters a minute, and it stays on the table and it doesn't hit things on the table.
Our interface requirements are that we will start it with a button. It will avoid the edge of the table to stay on the table. It will sweep up 100% of the debris that it rolls over, and it will spray down and mop up water.
And so for our mechanical analysis, our encoders will make sure that the drive motors are running smoothly on top of the table, and then a directly powered motor will sweep debris into a holding area, and then an ultrasonic sensor will prevent the robot from hitting any objects that are on the table, and then snap action sensors on either side of the robot will prevent it from just falling off the table, and then there's going to be a sprayer and mop combo near the back of the robot, and that'll mop the table as the robot moves on the table.
So for our failure analysis, our rollers could become debrushed, our reservoirs could fill up with gunk, it could fall off the table, it could run out of water, the mop could get dirty, the battery could die, the motors could bind or break, and our sensors could break.
Taking a look at the coding side of things, we have the setup code that'll set every component up. Upon pressing this button, we get a status light saying that it's on, and it'll play some sounds. From there, the Arduino will look for analog inputs from the snap action and the ultrasonics. If any of these detects something that is undesirable, it'll move the robot back, it'll turn in a certain degree, and it'll keep going forward. Otherwise, it'll just tell it to go forward. All while this is happening, we'll have the water jet spewing out water at a really low flow rate. Anytime we need to move anything, the Arduino will communicate to the DC motors. At the center of our electrical components, we have the Arduino Micro, which has a button attached to it. From there, we will wire the sweeping DC motor, the RGB LED strip, and the wet jet towards the rear. We have the encoded DC motors on either side. We have snap actions and the ultrasonic sensor.
So this is our 57-day schedule. We have already estimated the cost, estimated the parts, and estimated the plan, and we are filming right now. So that's the PDR. In between the PDR and the CDR, we need to build our prototype, finalize our budget, and finalize our cost. After the CDR, on day 30, we'll need to laser cut the acrylic, 3D print the inside parts, and gather the materials. And we're planning to do all of that before day 38 so we can build our final project for 5 days so we can test our program functionality, test and troubleshoot before the expo.
So this is our budget plan. Our overall budget is $338, and then we have all of our parts along with the purposes, amount, and cost per part. So we have an estimated total cost of $86. And then as you can see over here, we spent this much money, and then we have this much money